Hello guys, good evening. Am I audible? Can you hear me? Yeah, hi Ansh. Okay, I can see Ansh, Muskan, Mriganka, right? Okay, so guys, I request all of you to rename yourself with your name, okay? So there must be your name into the chat box if you're using it. Okay, Pradyun is there, Priyam is there, Sanjana I can see. Okay, I'll just wait for a few minutes. Let's other also join, okay? Then we'll start the session. All of you are from NPS Koramangala? Okay. Okay. So guys, what we are going to do today? Tell me, what are we going to start? At least subject you can say. Have you taken maths or physics classes? Chemistry, correct. So have you taken these classes, maths and physics? Okay, physics you haven't taken, only maths. Fine. How many of you like chemistry? Pradyun, do you like chemistry? Sometimes, okay, not always. Like, what is your favorite subject, by the way, out of these three? Maths, physics, and chemistry. Okay, Oro likes maths. What about Priyam? Sanjana, what about you? So Priyam also maths. Sanjana? Muskan, what about you? Chem and a bit of physics. Okay, that's nice. Ansh, what about you? Ansh Grover? Muskan likes chemistry mostly. Okay, Parvati likes maths. Okay, fine, guys. So, how many of you are looking for exams like I can say KVPY, JEE Mains, Advanced, NEET? Okay, UNS like physics. Fine. So, how many of you are looking for competitive exams like JEE Mains, Advanced, NEET, KVPY, BITSAT, or any other competitive exam? How many of you are looking for these exams? Or you are here only for the preparation of board exam? Shreya, Muskan, Pradyum, and got a response. Priyam, Mriganka, Sanjana, Parvati. Okay, so I guess all of you are looking for the preparation of competitive exams, right? Fine. So let's start first about the subject, right? We'll discuss what chemistry is, all about. and what all things we have to study here. Okay, so could you tell me, guys, like one more thing here I would like to understand how many subject or how many chapters you have in chemistry in your 10th standard. I think 4 or 5, right? 5 chapters are there in chemistry, correct? So 10th standard, you have only 5 chapters. And do you have any idea how many chapters we have here in class 11? 12, 20, 30, or randomly you are saying something. Okay, so it is roughly around 15 to 18, 15, 16, 17 chapters we have here. So you see, in 10th standard, you have only 5 chapters, right? And I guess similarly you have in physics and bio also, right? So you see, collectively you have physics plus chem plus bio in 10th standard. Here you have the entire chemistry, only that too for 11th grade, right? So obviously what point I'm trying to make, that the syllabus is very vast here. It is not like only 4 or 5 chapters you have to do. So in 11th grade, the syllabus is vast, right? First thing is that there are a lot of things you have to study over here. Second point, that is the understanding of the subject, right? First thing, you have to study a lot of things, and then understanding also here it is required. Means you should have the the concept you have to understand in depth. You cannot simply go through and you cannot mug the things in chemistry, right? So there are concepts, a lot of concepts are there. You have to understand those concepts properly, right? And the application of the concept is also here you have to take. Concept and its application. So understanding of concept and the application of concept, is two different things, right? So mostly what we think, that once you understood the concept, you can apply it, you can get questions based on those concepts. But it won't go like this always, okay? As far as competitive exam is concerned, obviously you have to understand the concept, but the application, if you're going to do the application of that concept, you will feel difficulty over there, right? So step 1 is to understand this, and step 2 is the application part of this. So mainly you have difficulty over here. I'm talking about in terms of chemistry now. Mainly you have difficulty over here. And most of the time what happens, once you go through the theory, the concept, you'll feel like that you have understood the concept properly. There's nothing more to understand, right? But the actual understanding you will have once you solve questions based on those concepts. Basically, it is the application part of it, right? So once you apply the concept, then only you'll get the actual thing, okay? So that's the two different things. This is required, these two things required for all those competitive exams, okay? So any competitive exam, if you write, you must have these two things very clear. You cannot mug up things and then write down the answer. It is not your question answer session, okay? You will have questions, there will be option, you have to choose the correct one, and then only you will get marks or rank or whatever it is, right? So that's how it is. First point I was trying to make is the syllabus is very vast. Understanding of concept is required, that too in very depth, right? And then application part of it. So you see the entire curriculum is designed in a very different way if you compare this with class 10th curriculum, right? So all of a sudden your approach towards the subject should change. Then only you can understand things, okay? So it is not like your 10th board exam or anything else where there are certain things, if you do not get it, you memorize it and then you'll go to the exams alone. Like that you cannot do over here. As far as chemistry is concerned, I'll tell you a few points here, because little bit of understanding of subject you must have in terms of how important the subject is for those exams. Okay, so chemistry, you see there are three different portions we have in chemistry. What are three different portions? Could you tell me? Anyone has idea of it? The three different portions we have. Okay, one other portion is organic. Okay, another one is inorganic. Next. Right, so little bit idea you have. Obviously, we have three different portions. That is physical chemistry. Then we have organic chemistry and inorganic chemistry. Okay, all three different portions in chemistry has different nature. Okay, so physical is more about derivation, formula, understanding, and then numerical questions based on that. Okay, so here mostly you'll get numerical questions like we have in physics or maths. Numerical problem you'll get here. So this is mostly all about is understanding concept and then formulas, and based on that we have numericals. Organic chemistry is you won't get any numerical problem.
That's what is on the hotspot to be. That's why he's not able to get into this. I'm not possible. I have to data.
Guys, you mute yourself. If you want to talk or discuss something with me, you can unmute and then talk. Okay? Yeah. Thank you, guys. So organic is, it's more about, we have reactions in this. You won't get any numerical problem into this one. Reactions. So how do we get different kinds of products? Okay. Preparation and properties of any chemical reactions, any chemical product, that we'll discuss here. Inorganic is also about chemical reactions and properties, but we discuss here the compounds like the elements, all those nitrogen, phosphorus, oxygen, carbon, all those elements we have, preparation method of that and other things, right? Organic deals with chemical reactions, this with chemical elements, compounds, etc., bonding of those elements, compounds, etc. Okay, so we have three different portions in chemistry, and their nature is also different from each other. So when you are going to understand physical chemistry, your approach should be different. Okay, for organic your approach should be different, for inorganic your approach should be different. Like for maths, your approach should be different than the subject like physics, and this should be different than the subject like chemistry or bio, right? So point is, here we can understand this different subject. So different types of understanding required here, and your approach should be also different for different subjects. Okay. Mainly what happens if you try to understand chemistry like you are studying physics, you won't get it. Okay. You will feel difficulty into this. Similarly, physics you cannot study the way you are studying maths. Okay. Again, you'll feel difficulty into this. So point I'm trying to make is all the subjects has different nature and has different difficulty level, right? So according to that, you have to plan your strategy, okay, for the subjects. Okay, why chemistry is very important, I have this input that most of the students, on like almost 70 to 80% of the students, feel like chemistry is a bit boring. Okay, little bit of extra information is required. In comparison to physics and maths, there are many other stuffs you have to memorize. You have to keep that in mind to solve the questions of chemistry. That's why most of the students feel that chemistry is a little bit boring in comparison to physics and maths. Okay. However, I do not agree with it completely. Yes, there are few things which you have to completely memorize. You cannot do anything into that. There are few things, but it is not boring in that way, right? Thing is, Chemistry, if you're going to see the pattern in JEE exam, I'm talking about JEE mains right now, you're going to have 20 plus 5 question. Total 25 question you'll get. Why I am writing down 20 plus 5? Because 20 you will have multiple choice, single correct answer. And 5 questions you'll get numerical value type. You'll get numerical value as the answer. So the pattern is like this. Similarly, we have in physics also 20 plus 5, maths also 20 plus 5. Okay. Now the thing is, if you are very good in chemistry, right? If you're very good in chemistry, these 25 questions, you mark my word, you can do this in 15 to 20 minutes, not more than that. If you are very good in chemistry, you can solve these 25 questions in 15 to 20 minutes. Now you see the exam starts, you have 3 hours of exam total, right? And in the first 20 minutes, you have finished the one of the portion, like physics, chemistry, maths, you have 3 portion. So you have finished chemistry already in 20 minutes, first 20 minutes, if you're very good into this, right? So rest of the time, that is 2 hour 40 minutes you have, that you can use easily for maths and physics. Okay, where you have some numerical questions, it takes a little bit more time than chemistry. So if you are very good into this subject, you can save your time, and that time you can utilize for maths and physics. Unlike this, if you're not good in chemistry, then you are definitely going to give at least 50 to 60 minutes. I'm telling you this, at least 50 to 60 minutes you are going to give to solve this 25 questions if you're not good into this, right? So the disadvantage of this is what? The other guy who is your competitor, if he or she is very good in chemistry, then they have done the portion of chemistry in 20 minutes and you are taking at least 50 minutes, right? So this half an hour is going to cost you a lot at the end of the exam, right? Because after this much of time, if you have spent in chemistry, you are not going to solve entire physics and maths problem. You won't get time for that. You'll feel that you are going out of time. You could not see even all the questions of physics and maths. So that's why this aspect, if you see, chemistry becomes very important as far as your preparation is concerned. Few questions in chemistry, you'll feel like, I'm telling you this with my experience. Okay, listen to me very carefully. Few of the question you see, it is like, if you know it, you can do it in a second. Like, okay, A, fine, gone. Okay, B, I know this question is B, gone. C, it's gone, like this. These kind of questions you can do in 1 or 2 seconds if you know it properly, right? But if you do not know, if you're not good in chemistry, you cannot leave these questions, because you will feel like, okay, this question I have studied somewhere. Maybe the answer is B or C. Oh no, it's A. These kind of thoughts will come to your mind. And the question like this that I'm talking about, it's very difficult to leave these kind of questions. Okay. Most of the students, 90% of the students definitely go with these questions. Whether you mark B or C or A or D, you will attempt this question. And you mark my word, if you're not very good in chemistry and if you're not sure with these kind of questions, you should leave, you should not attempt the question. Okay, but this is a difficult call, because you are having this idea that I have studied this particular thing, it is probably B, it is probably C. So in that frame of mind, if you are in that frame of mind, it is very difficult to leave these kind of questions. So what happens, actually you are about to put 1 or 2 seconds for this question, you have given 2-3 minutes for this, and you are attempting also, you are taking a call for this question, okay, I'm going with B, right? And mostly you'll get wrong answer in that case. Okay, so what happens eventually, the question was about for 1 or 2 seconds, you have given 2-3 minutes, but eventually you'll get wrong answer into this. So this cost you -1, right? So you have given more time and you did not get marks, you got -1, right? That's why this subject is very crucial out of the 3. This is the most important subject in your preparation. Okay, Chemistry usually it boosts your rank, right? It is a subject which boosts your rank in the exam. Okay, and all these things I am telling you with my 7 years of experience. Okay, I have been in this profession from the past 7 years. I have been teaching in Kota. How many of you know Kota, Rajasthan? Gurman Singh. Okay, why is it famous for? For what it is famous? This particular city. IIT coaching center, right? IIT NEET coaching center, right? It's there in Rajasthan, right? So I have been there. I was there associated uh, in a company called Career Point. Have you heard this name, Career Point? Yes, have you heard this name, Career Point, Kota? How many of you heard this name? You can type Y if you have heard the name. You can type N if you do not know about it. Okay, you do not know about it. How many of you know this? Acha, Pradyun has the idea. How many of you know this? Alan. Yes, all of you know because Alan is here in Bangalore also, right? But Career Point is not here in Bangalore. Okay, it is in Mysore. Career Point has a branch in Mysore. Anyways, so it's a similar kind of coaching institute. It's a very big organization. Okay, if you see top 5 or 6 organization in India, Career Point is one of the organization, right? So this how like you. So I have been in this industry from the past 7 years. I have seen the culture of Kota also, how they teach, how they prepare students for these kind of exam. And from all these experience, I am telling you, chemistry is going to be very crucial for your preparation. Okay, if you are very good in chemistry, you'll get a good rank. You can qualify the exam without chemistry, but for rank, chemistry is the subject, okay, which boosts your rank. Okay, another thing with chemistry is what initially, because there are few things which are connected, right? Chapters, if you see, if you do not study chapter A properly, you won't understand, suppose chapter D, because few concepts that we have studied here will use it here, right? So don't you think this, okay, we have just started now, like we'll do it in next month or after few days we'll do it. Don't pile up things. Okay, I'm telling you, since we are starting, you can finish this uh, the very same day, because once the course has been, when the course starts, you won't get time for those stuff which you have already collected, that okay, I did not study this portion properly, I'll do this later. You won't get time, I'm telling you. Okay, so from the first day you have to be very careful and sincere for your preparation. Okay, anyways, so there are a little bit of idea I have given you regarding the subject, how important the subject is, and what measures you have to take for this kind of subjects. One very important point I would like you to understand, and that is the preparation of notes. Okay, preparation of notes. All these competitive exam, okay, if you really want to prepare, you have to prepare the notes properly, whether it is physics, whether it is chemistry, or whether it is maths. Okay, because there are many stuff we have to understand. If you look at NCRT, suppose any one chapter of NCRT of any subject, you won't get all the things given there in NCRT, right? So here when we discuss all those things, so you will get a stuff of 3-4 different books in the class. We'll cover all those stuffs which are given in 3-4 different books. Okay, so what I am suggesting you, that for all the subjects you must have a separate notes. Okay, for all the subjects. Okay, and keep your notes properly so that before the exam you can revise it. Okay, You cannot study or read the entire book before your exam. Okay, so I'll suggest you must write down your notes properly. Whatever we'll do in the class, you must write it down properly. Okay, so that you can revise it before the exam, whether it is a school exam or whether it is any competitive exam. You must have the notes properly. Okay, that is very important. As far as chemistry is concerned, this thing is very, very, very important in chemistry, right? So you must write the notes in a separate book, right? Notebook for chemistry, for physics, for maths. Okay, so this is the one. Now, like I said, physics, physical, organic, and inorganic, three different sections we have. Okay, we are going to discuss some basic things of organic chemistry today. Okay, and the same thing you are going to have the test on coming Sunday based on this only, based on this class only. So whatever we'll discuss today, based on that only you will get question on the coming Sunday. Okay, so it is just a small test. You will probably have 15 to 20 questions for half an hour or so. Okay, I'm not sure with the time and other things, because just today only I have decided this. So I'll prepare the question paper. Mostly it will be 15 to 20 multiple choice question with single correct. Okay, so whatever we'll do today, that will be the syllabus of your coming test. Is it clear, guys? Yes. ठीक है. So this is the online class, right? So I'll request you, all of you, that you must interact with the teachers, like whoever is taking class. You must interact. It must be the both way communication. Otherwise, it is very difficult for us to fine. If mic is not working, you can type in here. But those whose mics are working properly, you can interact. Okay. Anytime you can interact, you can unmute yourself and talk, or you can text also there in the chat box, right? You can do that. Both way communication is very important, because we all are new, right? I do not know any one of you. Even you do not know me, right? So to make you understand certain things, to to get your difficulty, where you are having problem, what confusion you have, if you do not interact, I won't get that info, right? And then I won't be able to help you. So I'll request all of you, so do interact with me. Okay, if your mic is working, you can unmute yourself and talk, or you can text there in the chat box. Okay, but interaction is must required. Okay, anyways guys, so you must have done this chapter called IUPAC nomenclature in your 10th grade, right? IUPAC nomenclature in your 10th grade. Okay, so we have a chapter here in 11th grade that is also the same thing, nomenclature of organic compounds. Okay, nomenclature of organic compounds. So what is nomenclature? What do you mean by this? Why we require this particular concept, nomenclature? It is a naming of compounds, correct? So why we methods of naming? Very good, Pratyup. So why we need this? Why we need IUPAC? Because there are a lot of compounds, right? Suppose we have only 2, 3, 4, 5 compounds, correct? So we can give some name to that compound, and then we can memorize those names, right? But if you have 1,000 lakhs of compound, then we cannot name them randomly, and it is also difficult for us to memorize those names, right? So that's why IUPAC, that is International Union of Pure and Applied Chemistry, IUPAC has given certain rules, right? Based on that, those rules only will do the naming of compounds, right? So that we are going to study under this chapter, which is the nomenclature. Okay, so to do these kind of like to do this chapter, you must know those rules. Okay, what happens under what condition? Okay, what rules we have? Those things you should know. So I will tell you all those stuff, all those rules which are important. Okay, your job is to keep that in mind and apply that rules when we are doing the when you are doing the nomenclature of any compounds or in any exam, right? So first of all, you see, we have the classic. I'm just starting from the basic, right? Very basic we'll start with, and we'll go till JE mains, JE advanced level. Okay, so wherever you are having difficulty, you can stop me. Okay, it's very crucial, guys. Okay, because like I cannot see you. I'll keep on going like this. Okay, if you won't stop me in between, if you are having difficulty, then it will be very difficult for you to understand, right? So I'll start from the very basics, and then we'll go till JE advanced level, right? So first of all, you see, you have this chapter in your 11th grade also, right? Usually I'll do it in the last, like October or November like that. But this year I'm planning this to take as the first chapter for you, right? Because you have this idea, and it's a bridge course. So we'll do all these things in single attempt only. So organic chemistry is what? It's a portion of organic chemistry basically. Nomenclature is a portion of or a topic of organic chemistry. Okay, organic chemistry will study about organic compounds. In this subject will study about organic compounds. And what are organic compounds? Organic compounds are the hydrocarbons and its derivatives. Organic compounds are the hydrocarbons and its derivatives. And its derivative. What are hydrocarbons, guys? Hydrocarbons are the compounds which are made up of what? Hydrogen and carbon, as the name suggests, right? Yes, correct. So hydrocarbons are those compounds which are made up of hydrogen and carbon. What do you mean by hydrocarbon that you already told and its derivative? Right. So for example, if I take CH4, CH4 is a hydrocarbon, yes or no? CH4 is a hydrocarbon. What about this molecule? CH3, hydrocarbon, right? We can write down many examples like that. Okay, we can write some cyclic compounds also. This is also hydrocarbon, right? All these are hydrocarbon. Derivative means what? From hydrocarbon, if you remove one hydrogen, right, and add any other element or group over there, that becomes the derivative of hydrocarbon. For example, suppose we have CH4. Now from CH4, I have removed one hydrogen and attach one halogen atom here. What is this X stands for? X, guys, X in organic chemistry, we consider this as halogen atom. What are halogen atoms we have? Halogen atom, fluorine, chlorine, bromine, iodine. Correct? So this is the derivative of hydrocarbon, which is CH4 here. Another one we can write CH3OH. This is also derivative of this. We can also write CH3NH2, derivative of it. Okay, right. So all these compounds are derivative. Okay. So all these compounds are derivative of hydrocarbon, and these are hydrocarbons. Similar example. So organic chemistry is all about, yes, you can consider that, Anusha. You can consider that any hydrogen, if you replaced by any functional group, that becomes the derivative of that. Like for this one, we can say it is the hydroxy derivative of CH4. This is the halo derivative of CH4. This is the amine derivative of CH4. Are you getting it? All of you, are you getting it? Yes. Okay. So next thing is, in general, what we write, the derivative of organic compounds, we write as RX, right? Or ROH or RNH2. R is nothing but, what is R? It is the alkyl group actually. So in organic chemistry, R is considered as alkyl group. What is alkyl group? We'll discuss it again, right? Okay, we'll discuss this alkyl group later on. Now you see next here, if we talk about the organic compounds and its classification, right? So organic compounds, I hope all of you are writing it down. Yes? Yeah, you must write it down, because this is the only thing that you revise for the test. Okay, so must write it down. Organic compounds are actually classified into various categories. The first type we have, here, we call it as open chain compound and closed chain compound. Closed chain means cyclic compound. Open chain means acyclic. For example, you see butane, CH3, CH2, CH2, CH3. It is an open chain compound, right? But the same thing, if I write this way, it is cyclobutane. We'll see the naming also. But this is a ring structure, so closed chain compound, cyclic compound. Okay. Then further, this open chain compound again classified into two categories, and that is saturated and unsaturated. Further, this saturated compound is nothing but alkane. And so alkanes are the saturated hydrocarbon, we call it as. It is alkane. Unsaturated is, we have alkene or alkyne. Alkene or alkyne. Okay. Closed chain further classified into two categories, and we call it as homocyclic and heterocyclic. Okay, what is homocyclic, guys? Anyone? Homocyclic? Okay. Don't know. Fine, I'll tell you. Just you write down this classification. I'll give examples for all these. Okay, I'll give examples for all this. So homocyclic, and then this homocyclic compounds again classified into two categories, and that is alicyclic and aromatic compounds. Right? Aromatic compounds, again we have two categories. That is benzenoid and non-benzenoid. This is benzenoid, this is non-benzenoid. You copy this down, we'll see examples on this. Done? No, aromatic and aliphatic are not same thing. These are two different compounds. Okay. What is the general formula of alkane? Yes. So you know this CnH2n plus 2. For alkene, it is CnH2n. And for alkyne, it is CnH2n minus 2. Alkanes, we also call it as paraffins, another name. Alkenes, we call it as olefins, another name. Olefins, olefins. Okay. Just a second. Okay. I was just trying to take that in. Correct. Now you see the examples of this. I'll show you some examples here. Mainly, you know this saturated, unsaturated, everything, right? I think you have some doubt over here, right? Alkene is olefins, Olefins. Olefins. Okay. Now you see the another thing here. I said the compound is homocyclic. Homocyclic means only one type of atom present in the ring. Write down only one type of atom present. Generally, that is carbon atom. Type of atom. Generally, it is carbon atom. are said to be homocyclic compounds. Okay, so homocyclic compounds are what? We can have examples here. We can take this example, homocyclic. We can take this example, homocyclic. We can take this example, homocyclic. You know this structure? This structure, you know? Right. This structure, you know? Yes, correct, correct. So I'll discuss all this structure also after this. Okay. But you see, all these are carbon atom, this point. These are carbon atom. Only carbon atom present. Corners are carbon atom. Corners are carbon atom. So only one structure present, one type of atom present in the ring. It is homocyclic compound. Similarly, if you see heterocyclic, in this you write down more than one type of atom, more than one type of atom is present in the ring. Okay, so few examples I'll show you here. More than one type of atom, we can have this example. Nitrogen is present in the ring. This is structure. Okay, we can also have oxygen present like this. This structure, right? The name of this compound is pyridine. Okay, important formula, you must remember this. And this compound is furan, Furan. Okay, got it. One more structure we have like this, oxygen, but there is no double bond here. This compound we call it as THF in short. The name of this compound is tetrahydrofuran. Okay. Now in this, we have also discussed the two types of compound. We have alicyclic and aromatic. In this homocyclic, we have two types, alicyclic and aromatic. Okay. So these compounds, this one and this one, these are the examples of alicyclic compound. And this is the benzenoid compound. Because we have benzene structure here, so benzenoid. The other examples of benzenoid compound, we must have benzene character into this. Okay, so for example, if you write down this one, this also has benzene character. This is also a benzenoid compound. Okay, non-benzenoid compound, the other one, the non-benzenoid compound is this. This does not look like benzene, right? This compound we call it as non-benzenoid compound. So not much important this classification is, but you should know how the organic molecules are classified. Is it clear? Any doubt here, Dil? The cornered atoms are further attached to different atoms, is still heterocyclic. No, no. Heterocyclic will see only the atoms present in the ring. Right? Like this molecule is what? It is homocyclic only because only carbon atom is present. Yeah. Yes, all compounds which look like benzene structure are benzenoid compound. So basically it is similar to benzene. Aromatic compounds should be, you let it be now. There are many things you have to understand here. Aromatic compounds, I can tell you, benzene is an aromatic compound. Okay, so you have to understand a lot of things to understand aromatic compounds. Okay, so directly we won't go into that. Okay, I can tell you a few properties of aromatic compounds. It is highly stable compound. Benzene ring is an aromatic compound. Okay, so let it be. I don't want to go into that depth. You won't understand this now, so let it be for now. Okay, fine. Another thing you see, we have discussed the classification of molecules. The next thing is the different representation of organic compounds. Write down the heading, representation of organic compounds. Okay. Now in this there are three different representation which we call it as molecular formula. Okay. So first representation is dash formula, DASH dash formula. The another one is condensed formula, condensed formula, and the another one is bond line notation. Bond line notation. Okay. You know what is the formula of ethane? Ethane, you know what is the formula? C2H6. Okay. C2H6. Fine. All of you know this. So the structure of ethane, you see it is C single bond C, H, H, H. You know this structure, right? Anyone is out in this? I hope no. Right? Correct. So now in this you see all these dash are what? These are the bond. We have one carbon-carbon bond. We have 6 carbon-hydrogen bond present into this. Okay. So when all these bonds are represented by a dash, the formula is dash formula. Clear? The formula is dash formula because all the bonds are represented by dash. It becomes dash formula. Right? When all these bonds, mainly the bonds of carbon and hydrogen, right? This is the primary chain we have here. These are not the primary chain. So if you have to write down this into condensed formula, it will be H3C CH3. This is condensed formula. So basically in condensed formula, we do not represent carbon-hydrogen bond. Carbon-carbon bond we represent, but carbon-hydrogen bond we do not represent. Is it clear? I was about to talk about this, Kshitij. H3C and CH3. See what happens if you write this, correct? Basically, carbon-carbon bond is attached, no? Right? Basically, carbon-carbon bond is attached. So it's better to write H3C and CH3 like this. But if you write CH3 single bond CH3, this also does not make any difference. Both are same, right? But since carbon-carbon bond is attached, so we'll write CC bond and H3 this side. But in like, if you write this also, it's not wrong, it's right. Understood, Shitish? That's both way you can write. Will do, Shitish, just a second, will do. So this is dash formula, this is condensed formula. Now the bond line formula is just a line like this. It is bond line formula, where the two cornered atoms are carbon. You see this. So in bond line formula, we do not show carbon hydrogen bond. So in this, you see what you can keep in mind. Carbon is represented by a dot or by the corners. Carbon is represented by the corners, and carbon hydrogen bond is not shown here. We do not show carbon hydrogen bond. How many bonds carbon can form maximum? 4, right? So one thing you can conclude here, since all the carbon atoms can have maximum 4 bond possible, so for this carbon, one bond will already have here with this carbon and carbon bond. It means how many hydrogen present here with this carbon atom? How many hydrogen here will have for the carbon atom? 3, right? So each carbon atom has 3 hydrogen, right? Again, I'm telling you this, in bond line notation, we do not represent carbon hydrogen bond, right? We do not represent. It does not mean that hydrogen is not present there, okay? We don't represent this. It is understood that since the carbon-carbon only one bond we have here, it means it is clearly understood that each carbon atom has 3 hydrogen present on it. So this is dash formula, this is condensed formula, and this is bond line formula. Anyone has doubt in this condensed or bond line formula? Tell me, Oro. Drawing of circles around the shared electron. You're talking about benzene ring, Shitish. Dash formula includes all types of bond. Yes, all bonds will show. Yes, Shitish, your doubt I didn't get. Circle that will draw in the ring. You're talking about this. Let me just draw it here. Or you understood? You're talking about this bond.
I mean, around carbon, you have 4 electrons, and then hydrogen joins with it, like with one more electron, and then you draw a circle around the electrons.
You're talking about Lewis dot structure?
Yeah, like that.
Lewis dot structure is different, Shitish. Okay. However, these structures, we cannot say it is a Lewis dot structure, but the idea of for a molecular structure, we get from that theory. That is Lewis theory, we call it as. We'll discuss that in chemical bonding chapter. Okay. Like this you're talking about, no? Suppose this. This one, right? Okay, so each pair of dot represents one single bond actually here. That is what you can understand now. Each pair of dot represents one single bond. So answer to your doubt, what we can say, all these bonds that I have drawn here, I have written here, all these bonds has 2 electrons like this. So in Lewis dot structure, we do not show the bond, but we show the dot like this, which represents a single bond. Clear? When you represent electrons like this, then we'll draw a circle to show the number of electrons present in the bonding state. Okay. We'll do this in chemical bonding, by the way. Okay. So this is dash, condensed, and bond line. Okay. Someone was asking for propane, right? So for propane, the structure of propane is what? CH3, CH2, CH3. So dash formula of propane is C single bond C single bond C, H, H. This is dash formula of propane. The condensed formula will be CH3, CCH2, CH3. This is condensed formula. Bond line notation is the easier one, is this, where all these cornered atoms represent one carbon. 1, 2, 3. 3 carbon we have here. How many hydrogen this middle one has? This middle carbon has how many hydrogen? 2. Correct. One more formula you see. For this, the condensed formula is CH3C, CH2OH. And the bond line formula is this. Any doubt in this?
So which compound is this again, please?
Sorry?
So which compound is this?
This one.
Yes, sir.
What is the IUPAC name of this compound? Anyone? It's ethanol. Yeah, it's correct. OH is the functional group, alcohol is a functional group, and the name of this compound is ethanol. Okay. So we'll discuss this in this chapter only, how to name the compounds. We are trying to understand some basics of this organic chemistry. Then we'll start doing nomenclature. Okay. Then you will understand this, why the name is ethanol here. Acha, another thing, do you know what is sigma and pi bond? Do you know what is sigma and pi bond? No. Okay. Fine. Just for your understanding, we can discuss the details of this also. What is sigma, what is pi, how does these two bonds forms? Okay. But today we are not going into all those details. Okay. We'll try to understand some basic things so that you can count the number of sigma and pi bonds. How sigma and pi bond forms, we'll again discuss that in a chapter called chemical bonding. Okay, how bonding takes place, and that results into sigma or pi bond. But to answer this question, what you have to do, I'll tell you now. Okay, things you have to keep in mind, that I'll tell you. So write down the heading, sigma and pi bond. Okay. Yes, we also have coordinate bond, right? But see, there are two different types of classification of this also. On the basis of overlapping of orbital, there are two types of bond, right? So don't you compare this with covalent bond, coordinate bond, like that, okay? Ionic bond, don't you compare with that. It is on the basis of the way the orbital gets overlapped. Dumbbell shaped bond is not there. Dumbbell shaped orbital gets overlapped to form either sigma or pi bond, Anusha. Okay, so don't you think about all those. Okay, let me just be very specific over here, and I would request you to be very specific. If you like, if you discuss like this, you will miss the actual thing that I'm trying to understand now. See, chemistry is like, there are very high chances of getting deviated in the topic. Okay, so just you let it be all those things, types of bond and all. Here we have two types of bond that is present in the molecule, right? Sigma and pi both are covalent bond actually. We can say it is a type of covalent bond, but number of types of different bonds, again we have covalent, ionic, coordinate, etc. Okay, but covalent bond, under that covalent we have two types of bonds also, that is sigma and pi. So what all other types of bond, again that we'll discuss, we have a separate chapter for that, and that we call it as chemical bonding, correct? So that we'll discuss later. Today we are discussing only what is sigma and pi bond we have. Okay, so suppose I'll take one example and make you understand this. For example, I wrote one example here of methane. What is the formula of methane? Methane is carbon with 4 hydrogen, correct? Okay, so all these bonds are sigma bond actually. Sigma bond we represent like this also. This is the notation of sigma bond, like this. This sigma bond. Pi is this, pi bond. Okay, sigma and pi. So all these are sigma bond actually. So in organic chemistry, what you have to keep in mind, the first bond forms between the two atom in a molecule. Is sigma bond. Okay, the first bond between the two molecules is sigma, right? After formation of sigma bond, pi bond forms. Okay, this information is enough for you to identify how many sigma and pi bond we have. Okay, so pi bond forms after the formation of sigma bond, formation of sigma bond between the two atom. See guys, again I'm telling you, what is sigma bond, what is pi bond, how does it form, that you don't worry with right now. Okay, what you just need to know, that in a given structure, how do we identify that how many sigma and how many pi bonds we have. That is it. Just you need to count it as of now. Okay, The exact logic, reason behind this, everything we can understand, but it will discuss, we can discuss that, but that will be discussed when the time comes, right? So let the time come for that. This is not the right time to discuss the concept behind this. Again, I'm telling you, those concepts will be discussed in chemical bonding. That's what I was talking with you, that if you miss one thing here, right, you won't understand things in the other chapter, right? That's why it is very connected. Yes, it is. Give me some time, I'll just give some example. So this, you just, these 2 points you must keep in mind. First bond that forms between the two atoms is always sigma. After formation of sigma bond, pi bond forms. For example, I have taken this molecule, which is C double bond C, and there are 2 hydrogen here, like this. So in this, if I ask you, how many sigma bonds are there? Number of sigma bonds. So we'll count the bonds are, we have 1 sigma bond here, carbon hydrogen, 1 sigma bond here, carbon hydrogen, 1 sigma bond here, carbon carbon, 1 sigma bond here, carbon hydrogen, and 1 sigma bond here, carbon hydrogen. The other bond here, which forms after the formation of carbon carbon single bond, this bond is the pi bond actually, right? So number of sigma bond here is 2, 4 plus 1, 5 sigma bonds, and number of pi bonds, if I count, 1 pi bond. Is it clear? Is it clear, guys? Carbon carbon sigma bond you also have to count. Okay, suppose we have a molecule, say this one, H, C, triple bond C, and H. How many sigma bonds? How many sigma bonds and how many pi bonds? Yes, we have 3 sigma and 2 pi. 1 sigma here, 1 sigma here, 1 sigma here. And since 1 sigma has been formed, so other 2 bonds are the pi bonds. So 3 sigma and 2 pi. Is it clear? So only this information you just want to have now to solve questions, few questions, right? So with these 2 examples, what we can conclude? We can easily conclude this, that in a double bond, we have 1 sigma bond and 1 pi bond, correct? But in a triple bond, what happens? Number of sigma bond is again 1, but the number of pi bond becomes 2. Is it clear? Clear, understood this? Correct. So just you need to know this thing, that how do you identify sigma and pi bond at this level, okay? Again, I'm telling you how these bond forms, the concept behind this, everything we'll discuss in other chapter, that is chemical bonding. So few examples I'm writing down here, and you just have to tell me how many sigma and pi bonds are present. Okay, for example, suppose I'll write down the heading, calculate number of sigma and pi bond. Number of sigma and pi bond. Do this question. All 5 you do and let me know. Okay. Still trying? I can see many responses here. Oh, that's good. Very good, guys. Fine. I'll just do this. You just check your answer. Okay. So in this case, we'll have we'll have 6 sigma bond and 0 pi bond. In this case, we'll have 2, 3, 4, 5 plus 3. 8 sigma bond and 1 pi bond. Here we have 6 plus 6. We have 12 sigma bond and 3 pi bond. 5 plus 2, 7 plus 4, 11. 11 sigma bond and 2 pi bond. 3, 4, 6, 7, 8 sigma bond and 2 pi bond. How many of you have got all correct answers? This is the answer. You just cross check this. It's just a calculation. You can have some, you can do some mistake also. Just cross check this and just check your answer. Two. Do you have doubt in any question? Which one is 9? The first one. Is it? Did I make some mistake? Just a second. 1, 2, 3, 5, 7, 9. Yeah, first one is 9. First one is 9, correct. This is 9. 1, 2, 3, and 9. Correct. Any other doubt you have? Did you understand the fifth one? How it is 8? Triple bond. Very, very good, Auto. So we have here carbon nitrogen triple bond, right? So that's why we have 1 sigma and 2 pi. This is a cyanide group actually. CN is the cyanide group, and here the bonding is this. We have C triple bond N. This you should know. Clear? Okay. Now, okay. In fourth one, what is the doubt? See here, fourth one. This carbon has 2 hydrogen here, H and H. And all these carbon has one hydrogen. Carbon must have 4 bond. This is a possibility. So we have 5 sigma bond in the ring plus 6, 7, 9, 10, and 11. 11 sigma and 2 pi. Is it clear? Okay. Now, the next thing is, suppose if I give you one molecule, which is C2H6O. C2H6O. This is the molecular formula given. Could you draw the structure of this? What is the possible structure of this molecule? What is the possible structure? So you are writing it as, okay, let me see this. Kshitij is getting aldehyde or ketone. Okay. Oro is saying it's an alcohol. Anusha is getting alcohol. Okay. Kshitij is saying he's stupid. Okay. Ans is saying ethanol. Okay. Right. So now you see the what confusion comes to your mind when you look at this molecule. you started thinking about whether it is aldehyde or ketone, or most of you were saying alcohol, right? But this is a genuine question that should come to your mind, but that the given compound, whether it is an alcohol or aldehyde or ketone or any other compound, okay? So how do we get this idea that whether it is an aldehyde, ketone, or an alcohol or other compounds? So for that, what we do, we'll try to found a value here, and that value is known as double bond equivalent. Okay, so there is a concept here we use, formula actually here we use, that is double bond equivalent. We also call it as degree of unsaturation. Degree of unsaturation. In short, we write it as DBE, and this one is DOU. Both are same thing actually. Now, we have a formula, and this formula based on observation. There's no proof or anything like that. This formula is based upon observation, and the formula is DOU or DBE, both are same thing, is equals to C plus 1 minus H plus X minus N divided by 2. Right? Where C is the number of carbon atom in the given compound. Like here it is 2. H is the number of hydrogen atom. X is the number of halogen atom. N is the number of nitrogen atom. Right? This is the thing we have here. If oxygen is present in the molecule, so we'll ignore that particular oxygen. Wait. I am explaining this, Arya. Just give me 2 minutes. I'll explain it again. Okay, let me finish this first. Okay. CHXSXN, this number of carbon, hydrogen, halogen, and nitrogen. So the DBE means it is double bond equivalent or degree of unsaturation, right? So suppose you get the value of DBE when you calculate with this formula. If the value of DBE is 1, it means the given molecular formula will have either one double bond, or one ring structure into this. Means one cyclic ring we have into this. Okay, so basically in short, let me just conclude this, right? DBE value, if you are getting it as 0, right? If you are getting it as 0, it means whatever molecular formula is given, when you draw the structure, you won't have any double bond or ring structure. Any double bond or triple bond or ring structure in the molecule. It's not possible. If DBE is 2, just last thing you won't get is 2. Just you try to understand this. So DBE double bond equivalent is 2. It means we can have 2 double bond, because in one double bond we'll have 1 pi bond. So 2 double bond will have 2 pi bond, hence DB is 2. So either you can have 2 double bond, or we can have 1 triple bond, or we can have 2 ring structure, or we can have 1 double bond plus 1 ring structure. So basically double bond equivalent, you won't get any fractional value first of all. Whatever DBE you are getting, equal number of pi bond or ring will be there in the molecule. Did you get it? Like in the molecule, we have 2 ring structure, 2 ring will be there. Okay, in the molecule, with 2 ring present. Like for example, you see this. First of all, you copy this down. I'll explain this again. Understood? How do you get this formula? That's what you are asking. So there are like the scientist name is not given. That is not important also. But yes, based upon the observation, they have given this formula. This hidden trial method. By that only they got this formula. So one of the questions Shubhi is asking that what is a 2 ring structure? I'll tell you what is a 2 ring structure. Okay. First of all, you have to understand this. The number of DBE you are getting in the structure of that molecule, the equal number of either you have pi bond or you have ring structure. That's why when DBE is 1, we can have 1 pi bond or 1 ring structure. Both not possible, either 1 pi bond or 1 ring. If you have no DBE, 0, it means there is only single bond. No double bond, no triple bond, no ring structure. If you have 2 double bond, 2 DBE, it means we have many different possibilities. We can have 2 pi bonds. We can have only 1 triple bond, because in 1 triple bond, we know there are 2 pi bonds. Or we can have 2 ring possible, or we can have 1 double bond or 1 ring. Now the question is, what is 2 ring structure? I'll give you one example, and with this probably we understand. Suppose if I ask you to draw the structure of C7H12. Draw the structure of this. Wait, Otto. C7H12. Right. Now, if I ask you to draw the structure of this, okay, what you will do, because you may have various different possibilities. Okay, you can't even think what is structure. Yes, you can say it is an alkyne, but there are other possibilities also. Alkyne is not wrong, but there are other possibilities also, right? So how do you get this idea that whether you have an alkyne or alkene or what possibilities? So for this, what you do, one thing is what you can just hit and trial. You can draw a random structure and then check whether there is any double bond or triple bond is possible or not. One thing is that. But to reduce the effort, what you can do, you can calculate, first of all, you can calculate DBE. Could you tell me what is the value of DBE you are getting for this molecule? What is the value of dBe? Yes, we do not know. We only write the possible structures, Shirish. What all different possible structures we may have. That only we can find out. We cannot say the structure is this only, right? But we can say these are the possible structures with this formula, right? Okay, so dBe you are getting 2, it's right. The formula we use 7 plus 1 minus h is 12. There is no x, there is no n, divided by 2. So that will be 8 minus 6, 2. So we are getting 2 double bond equivalent. So what are the possibility we have? First possibility is what? We can have 2 double bond in the ring, 2 double bond possible. We can draw a structure with this formula which has 2 double bond, or we can draw a structure with this formula. We can have 1 double bond. And 1 ring. This is one possibility, right? We can also draw a structure in which we have 2 ring present. We can also draw a structure in which we have 1 triple bond present. So basically, the structure could be an alkyne, an dialkene, a double bond with ring, or 2 ring. Like for example, one possible structure of this we have is this one. We can have 2 ring like this. You see the molecular formula for this compound is C7H12 only. You can check that. What is the molecular formula for this compound? Could you tell me? Okay. One possibility is this. Another possibility is this. One more structure we can draw where we have a 4-membered ring, a double bond in the ring, and then CH2, CH2, CH3. You see, this structure also has same molecular formula. Like this, we have many different possibilities. Cycloheptene also we can draw. That is also correct. Cycloheptene also we can draw. So you see here, a big chain without 2 double bond. Big chain without 2 double bond. We can have one triple bond like this. See, 2, 3, 4, 5, 6, and 7. And we can have triple bond like this. Okay, guys, did you understand this? How many of you understand this? Point I'm trying to make is what? You can draw many such structures. You can draw many such structures. The possibilities are this. I'm giving you just few possibilities. Okay. So what you do, whenever a molecular formula is given, you find out double bond equivalent. Okay. And mostly you'll get 0 or 1. right? That gives you an idea that whether in a given compound we can have how many double or triple bonds possible, right? So just to keep one thing in mind, double bond equivalent means it represents either the number of pi bond or the number of ring present in the molecule. If it is clear, you can type, all of you can type CLR in the chat box. Fine, fast guys. Okay, one question I got, how do we calculate total number of possibilities? Guys, we do not have any formula for that. You can keep thinking on this and draw the structure this way, right? And then you will get the number of possibilities. Okay, so generally it is very difficult to do these kind of questions in the exam because you do not have that much time there. Okay, so that's why they do not ask you the double bond equivalent to and draw the possible structure for that. It is very easy when dbe is 0 or 1. So most of the time you'll get question where the double bond equivalent is either 0 or 1. You won't get it with 2. But if it is 2, it takes a lot of time to think, and if even if you miss one single structure, the entire question will be wrong. Your count will be wrong and you'll get -1 marks. Okay, so what I'll suggest, first thing, that you won't get such questions where dbe is 2. If it is coming out to be 2, then you do these kind of questions in the last, when you have suppose 10-15 minutes left. Then you can think about the structure and draw one by one, and you can count the number of possibilities. We do not have such formula which can give you the number of possible structures. Did you get it? Did you get it, all of you guys? Tell me. Correct? Now the first question I have asked you here, which is this, right? You see this one, C2H6O. Now, like you said, some of you were saying alcohol, some of you were saying aldehyde ketone. So what I'll do, what is the difference between alcohol and aldehyde ketone? The major difference is what? For alcohol and aldehyde ketone, if we are taking the basic compound, obviously for aldehyde, the DBE should be what? Should be 1. For alcohol, DBE should be 0. So what we'll do, we'll find out the DBE value of this. What is the DBE value of this? Tell me. 0. Very good. So you are getting DBE as 0. So if DBE is 0, what is the structure we can draw? You see this? It's not 0, it's O, right? In the formula, it is C2H6O, that is oxygen. And if oxygen is present in the molecule, you have to ignore that. Like I said, that there is no proof for this. It is just based on observation, right? So you have to ignore oxygen into that. You don't have to count. So suppose I get this formula and we have to draw the possible structure of this. The first step is to find out DBE. And once you find out DBE, it was 2 plus 1 minus, there is 6 hydrogen, there is no halogen, there is no nitrogen, divided by 2. So DBE is 0. It means we have only single bond present here, right? So the only possible structure with single bond is either we can draw an alcohol, which is CH3CH2OH, or we can also draw a compound which is an ether, CH3OCH3. These two structures are possible here. This is also possible, no? Ether is like alcohol. Ether is also a functional group, guys. This, like alcohol, is what? OH. What is aldehyde? C double bond OH. What is ketone? C double bond O, like this. Similarly, ether is also a functional group, which is this. O, like this. It's a functional group. You see, with this formula also, CH3OCH3, the molecular formula is same, C2H6O. And with this alcohol also, molecular formula is same, C2H6O. Is it clear, all of you? Yes. So this is the two possible structure with this formula, correct? Have you heard the term isomerism? Have you heard the term isomerism? Yes. So these two are what? You see these two compound. One is alcohol, another one is ether. And their molecular formula is same, C2H6O, right? So these two molecules have same molecular formula, but they have different functional group with it. So this kind of compound, we call it as functional isomers. Have you heard this name, functional isomerism or functional isomers? So you see the concept here, right? Another definition of functional isomers are what? They have same molecular formula and they have same value of DBE, degree of unsaturation, right? So the molecule which has same value of degree of unsaturation and they have same molecular formula are functional isomers of each other. Aldehyde and ketone, yes, Kshitiz, very good. Aldehyde and ketone are also functional isomers of each other. Okay. Now you see, we have discussed, and I hope you all of you have understood what is the use of double bond equivalent, that is DBE. It gives you a fair bit of idea that what could be the possible structure given for a molecular formula. Okay. Based on this only, if I ask you this question, could you tell me what is the possible structure of this we have? Yes, 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 it is. We can say like aldehyde and ketone, we can say ether and alcohol are also functional isomers. We can say, provided their molecular formulas are same. Okay, could you tell me the possible structure of this compound? C3H6O. Who is at the end? Okay, like Mriganika. Mriganika, am I pronouncing it right? Yes? Mriganika, correct? Okay, close enough. Thank you. Okay, no issue. Right. So, like Mriganika, what we say, we can ignore oxygen while calculating DOU, right? But when you have to write down the structure, oxygen you have to write there. Understood? I'm sorry. Yes, fine. Oh, you're getting all alcohol. Oishik. What is the pronunciation? I'm not getting it. I thought it was still talking about. Anyways, ignore. I understood. Acha, chalo, what are you getting this? DBE value. Tell me, all of you. What is DOU here? 1, correct? So I think I should not, calculate this, but let it be. I'm just doing it now. 3 plus 1 minus 6 plus 0 minus 0 divided by 2 gives you 1. So when DOU is 1, so this could not be an alcohol. This is for sure, right? Because alcohol, there is no double bond into this. This could not be an alcohol. So it can be either aldehyde or ketone. It could not be an acid, because in acid we have 2 oxygen. We have only one here, right? So the only possible structure of this is CS3 C double bond O. CS3, it is a ketone, and the another possible structure is CS3 CH2 C double bond OH. You see, this DBE is 1 because we have a double bond here, right? So again, these two molecules has same molecular formula but same value of DBE. It means they are isomers of each other. And what kind of isomers? Since they have different functional group, so they are functional isomers. Now you got the new definition of isomers, yes or no? Have you heard this definition before? Okay, that's good. Correct. So I'll write down some structure here. You just tell me the value of DBE. You don't have to count the number of possible structures can draw with this. Just you tell me the value of DBE for these structures. Okay. So quickly, I'm just writing it down. C4H10, C4H6, done all of you? Okay. So for C4H10, DBE value is 0. C4H6 dBe is 2. For this dBe is 4. For this one dBe is 5. And for C4H10O, 4 plus 5 by 2 is 0. Achha, how many of you have done third one and got the right answer? Okay, fine. How do you do this? How many of you have done like this? See, how many carbon atom we have here in this? Carbon is 6. And how many hydrogen here? C6H6. Then we use the formula 6 plus 1 minus. You have done this way? All of you? The same method you have used, right? Yes, correct. So you can do by this method, but this actually not required here. Why? I'll tell you. Because the structure itself is given, no? Suppose dBe you have to find out, and if the structure is given, you don't have to write down the formula for this and then find out dBe with the formula given. In this structure, how many ring we have? Tell me. How many ring in this structure? One ring. How many pi bond we have in this? 3 pi bond. So 3 plus 1 is what? 4. One double bond means 1 sigma and 1 pi. Right? Understood this? So when structure itself is drawn, then you don't have to write down the condensed formula of it and then use this formula of dBe and get the answer. That is not required. Just you count the number of ring and pi bond present in the structure and it's done. Upper limit of dBe, it can be anything, you do not know. There are many complex structure, okay? So there's no upper limit. Obviously, we cannot say it is 1000 or like that, but there are various complex structure we have, right? So it is not defined actually. Yes, possible, can be more than 2, easily, right? Now suppose in the fourth one you see, you have to find out dBe. So you don't have to count the carbon and then hydrogen and then oxygen, write down the formula and then use formula of dB and get the answer. That you don't have to do because the structure itself is given. Tell me how many pi bonds we have here in this structure? Yes, we have 3 pi bonds. Correct. So 3 लिख लिया. How many ring we have in this structure? 2. So 3 plus 2 is what? 5. Now suppose in this structure, I'll give you one more example here. We have a benzene ring, and on this ring we'll use Cn here. Could you tell me the dBe value of this? Yes, correct. You can say that, Kshitish. Number of pi bond plus ring if the structure itself is drawn. Okay. Now in this one you see, we have cyanide group, correct? So cyanide is C triple bond N. So tell me, number of pi bond, we have 2 here, 3 here, 5 pi bond, and there is one ring, 6. Did you understand this? Okay. Okay. The another term we have to understand is the degree of carbon atom. All these are, guys, very basic, okay, very basics of organic chemistry, which we use in all the chapters basically. There's no specific chapter defined for whatever things we are discussing now. Okay, it is a basic understanding of organic chemistry. Degree of carbon atom is what? We can say the carbon atom is 1 degree carbon or primary carbon, both are same thing. 1 degree means primary. Yeah, I'll give you a break. Just let me finish this. Just 5-6 more minutes. Okay, it's just 5-6 more minutes. 1 degree carbon or primary. We'll have 2 degree carbon. We also call it as secondary carbon. 3 degree carbon, which is tertiary carbon. TERTIARY, tertiary carbon. Okay. How do we define this? 1 degree carbon is the carbon atom I'll explain. Wait. Just a second, guys. 1 degree carbon is the carbon atom that is attached with only one carbon, right? 1 degree carbon is the carbon attached with only one carbon. Similarly, 2 degree carbon is the carbon attached with only two carbon. 3 degree is the carbon attached with only 3 carbon. We can have another one also. I forgot to write here. That is 4 degree, or we call it as quaternary. Quaternary carbon. And this is the carbon which is attached with 4 carbon atom. Got it? Now, based on this only, we have definition of primary, secondary, tertiary hydrogen. Okay. So the hydrogen which are attached with primary carbon are called primary hydrogen. So with this carbon, the hydrogen attached is called primary or 1 degree hydrogen. Similarly, secondary hydrogen are the hydrogen attached with secondary carbon, right? So it is secondary hydrogen. Tertiary carbon has tertiary hydrogen. The hydrogen attached with tertiary carbon are called tertiary hydrogen. Quaternary carbon means the carbon which attached with 4 carbon atom. So here we have no hydrogen because the valency is already complete. There's no hydrogen attached with quaternary carbon. The definition is clear. Yes. So there's a whole event with double bond. And also refer degree, yes. So every carbon in a diamond is quaternary carbon. Yes, correct, Shitish. You can say. It is not with double bond. With double bond, respect that we don't say that. With respect to double bonded carbon atom, we define alpha carbon. We'll discuss that later, Pradyul. Okay? It's not with this. So sometimes what happens, they'll give you the structure and ask you to find out the number of quaternary carbon, number of tertiary carbon or hydrogen accordingly, right? So for example, I'll take one example here and try to discuss all these things here. So suppose we have an example. I'll write on the next page. Suppose we have a structure like this. And in this structure, there is one more structure attached like this. And here we have one carbon with CH2, CH3. Here we have again CH3 attached. And here we have CH3 attached like this. Could you tell me how many 1 degree carbon we have in this? How many 2 degree carbon we have in this? How many 3 degree and how many 4 degree carbon in this structure? Done? One degree, 3, 2 degree, 7, 3 degree, 3, 4 degree, 1. Okay. So I'll start from here. This is 2 degree, 2 degree, 3 degree, 3 degree, 2 degree, 2 degree, 2 degree. This one is 3 degree. This is 2 degree, 4 degree, 1 degree, 1 degree, 2 degree, and 1 degree. Correct? So how many 2 degree we have? 1, 2, 3, 4, 5, 6, and 7. Number of 2 degree is 7. Number of 1 degree is 1, 2, 3. Number of 3 degree is 1, 2, 3. And number of 4 degree is 1. Okay. Now 1 degree carbon has how many hydrogen? Has 3 hydrogen atom. That we can also conclude. 2 degree carbon has 2 hydrogen atom. Each carbon has 2 hydrogen atom. And 3 degree carbon has 1 hydrogen atom. And 4 degree carbon has 0. Okay. So number of hydrogen atom, if you have to count here, that would be 1 degree has 3. So 3 into 3, 9 hydrogen atom. 2 degree has 2. So 7 into 2, 14 hydrogen atom. 3 degree has 1. So 3 hydrogen atom. And 4 degree has 0 hydrogen atom. That is also you can count. Yes, if it is given, then you can count like this number of hydrogen also. Okay. One more structure you see. Tell me fast. 1 degree, 2 degree, 3 degree, 4 degree. There's no 1 degree in this. How many 2 degree we have? 2, 2, 3, 4, 5, 6. 6. How many 3 degree we have? 2. This one and this one. And there's no 4 degree in this. Understood this? Okay, fine. So we'll take a break now. We'll resume the class at 6:30. Correct? You don't have to leave the meeting. Just you mute yourself and let it be as it is. Okay, we'll resume the class at 6:30. Correct? You just mute yourself, all of you. Thank you. Hello? 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 Can you hear me? Yeah. Yeah. Okay. This is it. Okay. So we have discussed all those basic stuffs which is required. I think someone is talking. Let me. Okay. So now we are going to see the IUPAC nomenclature. Okay, which obviously you have some idea. Suppose I'll take one example. Just let me check whether you know this thing or not. Suppose I'll take one example, butanol. Butanol. Could you tell me what is the root word in this name? What is the primary suffix? What is the secondary suffix? Could you tell me this? Butanol. Till 7:30 we have. You know what is the root word? Okay, you see, in this one, the root word is but. But is the root word. Primary suffix is "-ane" and secondary suffix is "-all". That is for alcohol. So if you write down the structure of this, that would be CS3CH2 CH2OH. This is butanol. Okay. So root word, primary suffix, secondary suffix is this. Okay. Now in this only, if I write down this structure, suppose 2-bromo, 2-bromo-butanol. So the structure of this, if I draw 2-bromo-butanol, the structure is this: CH3CH CH2OH. Sorry, CH2CH2OH. 2-bromobutanol is this: CH3CH CH2CH2OH. So we have 2 bromos. This should be 2, and here we should have CH and 1 bromine attached over here. Okay. This molecule is 2-bromobutane. So the name here, if you see, 2-bromo is the prefix we use there. It is a side chain, or this is the prefix. prefix, or we also call it as side chain. So side chain or prefix is nothing but the branch. Okay. But is again the root word, in is the primary suffix, and ol is the secondary suffix. So any compound is generally made up of the prefix, which is there if there is any side chain, plus the root word, plus the primary suffix and secondary suffix. Prefix will be there if there is any side chain, then only prefix will be there, otherwise prefix won't be there, like we have seen in the first case, that is butanol. Understood? So in general, if I say, or if I talk about the root word, what all root word we have? We can have myth, we can have eth, prop, but, pent. After pent, what we have? Hex, hept. Then we have oct, non, dec. 11 carbon is undec. 12 carbon is dodec. Right? So myth, if you have only one carbon atom, C1 is myth, one carbon, C2 is eth, C3 is prop, C4 is but, C5 is pent, C6 is hex, C7 is hept, C8 is oct, C9 is non, C10 is dec, C11 undec, C12 dodec, C13 tridec, like this we go. Okay? Do you know this? Then primary suffix, you see, it actually gives the idea that whether there a given compound there is any unsaturation or not. Means double or triple bond. So it can be ane, it can be ene, or it can be ine. This is for alkane, alkene, and alkyne. But when we add primary suffix to the secondary suffix to the primary suffix, we remove this e, the terminal e. So note this point, the terminal e of primary suffix of primary suffix we usually remove when the secondary suffix is added to it. Understood? Done? Yes, Br should be on the second carbon atom because the position of Br is mentioned there, 2 bromo. The terminal E of primary suffix we usually remove when we add secondary suffix to it. Something like this I told. I do not remember the exact line, but the meaning was this. Anyways. Okay. So this is primary suffix. Now secondary suffix is what? Secondary suffix is associated with the functional group that we have. Okay. You see the secondary suffix, few examples we'll see here. And then when we do the functional group nomenclature separately, we'll discuss that again. So secondary suffix is like we have OH, that is alcohol. And the suffix of OH is all. If you have CHO, that is aldehyde, the suffix is al, all and al. If you have ketone, the suffix is on. Okay, and there are many other things we have, okay, which we'll discuss separately in the functional group nomenclature. But generally, whenever you do the nomenclature of any compounds, we have these four things only. We'll have prefix, we'll have root word, primary suffix, and secondary suffix. Prefix depends upon depends upon the side chain, whether we have it or not. Understood? Right. So if side chain is not there, what is side chain, that also we'll discuss. Then prefix won't be there. In general, the the structure of any molecular compound, the structure of the name is prefix plus root word plus primary suffix plus secondary suffix. So in all these IUPAC nomenclature, you have to identify these four terms, and then you just club these to get the name of the compound. Okay. The same thing we are going to apply to the nomenclature of alkane, alkene, and alkyne. Okay. One last thing I would like to add here: root word in any compound is generally the longest possible chain. Longest possible chain. Okay. Now we'll start doing some example here so that you can understand how to do nomenclature. I guess you have a fair bit of idea of this thing, nomenclature. How many of you, I said root word is generally the longest possible chain in the given compound. Root word will be the part which is the longest possible chain. Got it? How many of you were associated with us in your 10th grade? Shatish, what are you doing? Okay, 1, 2, 3, 4. And okay. Oh, shit. So I think how many of you? Acha, okay, there's no issue. So like I think 5, 6 of you were there with us, right? In your 10th grade. Who taught you chemistry, guys? Okay, that's good. Fine. Right. So write down the heading: nomenclature of alkane. I request all of you to write down the notes properly. Nomenclature of alkane. Okay, there are some rules. Like I said, we have to follow rules here. So rule number 1, you write down that you have to do. Select the longest chain. Rule number 1, you write down. Select the longest chain. Okay. Rule number 2, quickly guys. Rule number 2, rule number 2, if in case of two same number of carbon chain, in case of two same number of carbon chain, the one which has more number of locants, the one which has more number of locants or substituents. Rule number 2, I said this one, locants, the one which has more number of locants or substituents will be considered as the parent chain. Okay, will be considered as the parent chain. Yeah, rule number 2 is in case of two same number of carbon chain, in case of two same number of carbon chain, the one which has yeah, I'll explain. Just you write down the rules. I'll take example and explain each and every rule. Okay, first you finish this. The one which has more number of locants or substituents is the one which has more number of locants or substituents will be considered as the longest chain. Rule number 3, the substituents or locants must have the least possible number. Longest or parent chain are same thing. I'll explain this. Just you finish the rule first. Okay, write down the rule. I'll explain each and every rule. The substituents or locants must get the lowest possible number while numbering. Locants must get the lowest possible number while numbering. Rule number 4, if more than one locant is present, then it will be written. If more than one locant is present, then it will be written in alphabetical sequence. Okay. Now you see the examples here. Suppose if I write this, 1, 2, 3, 4. This is the compound we have. You don't have to do the numbering, the naming of this. What is the longest chain in this? How many carbon atoms are there in the longest chain? Could you tell me? If you go like this, you'll get 7. 1, 2, 3, 4, 5, 6, 7. But if you select this one, start from here and select this one, the number of carbon atom is what? 8 here you see. Hence, this is the longest carbon chain. Even if you want, you can select like this also. This is also longest carbon chain. And both are the same thing. This you can take, or this you can take as the longest chain. And longest chain, we also call it as the parent chain of the molecule, right? So for nomenclature, first of all, we'll select the parent chain. In short, we write it as PC. Okay, parent chain. This is rule number 1. Okay. Could you tell me the number of carbon atom in the parent chain of this molecule? Number of parent chain here. So it will be this, right? Okay. So like this, we select the longest possible chain. In fact, you can take this also as a parent chain from here to here. Now, once you select the longest possible chain, whatever the group atoms attached to the longest chain here, that is known as the substituents. Like in this chain, this is the group attached, right? Sorry. This is the group attached, right? So this is known as the substituents, which we also call it as locanes, which we also call it as side chain. Here the substituent, there are more than one substituents also possible. This one and this one, both are substituents, locanes or side chains, right? This is one thing. Now, if you select this one, see this. How many carbon atoms are present in the longest chain here? Could you tell me the name of this compound? Tell me the name of this compound. Just give it a try. See, we have two things here. If you select this chain, you see this, there are two possibilities. Number of carbon atom in this chain is how much? Number of carbon atom here? 7, right? Okay. Now, if you see this one, what is the number of carbon atom we have here? Just a second. The number of carbon atom we have here, you see this chain. How many carbon atoms we have here? Again 7, right? So this chain also has 7 carbon atom, and this chain also has 7 carbon. This is rule number 2. So when the 2 carbon chain in the same molecule has equal number of carbon atom, then the question is which one will select as the parent chain or the longest chain. Okay, what the rule says, that the chain which has more number of locants, right? So how many locants we have in this chain, in this parent chain? How many locants we have? Could you tell me? Locant means branch. We have only one. This is a bigger one, right? This is the only branch we have here in this chain. But if you select this as the parent chain, how many branch we have? How many locants? We have 1, 2, and 3. Right? We have 1. This is the whole one branch. Another branch is this methyl group. Another one is this, again, methyl group. So in this chain, we have 3 locants, 3 branch, 3 side chains. But in this straight chain, we have only 1. Right? That's why the green one is the parent chain we have here. This is the PC, parent chain of this molecule. Any doubt? Hello? Yeah, am I audible now? Correct. Okay, yes. Wait. We'll name this. Just we'll try to explain the rules that I have written you. We'll name these compounds. Okay. So what I have done in this two, obviously the parent chain is the green one. So this we are not considering. We have 3 substituents here, right? So just we'll ignore this. Okay. Now once you select the parent chain, you have to number the carbon atom. Means numbering why it is required, because you have to define the position of the substituents, whether the substituents present at first carbon, second carbon will count. Let me just explain this, Anusha. Just give me 2 more minutes. You'll understand this. Okay. Right. So now we have the longest chain. next is we have to give the position, we have to assign the position to these locants, right? So for that, we'll number the carbon atoms. So numbering, we can start from this side and this side, depending upon what position we get from this side and this side. So for this numbering, we have rule number 3, that is the substituents or locants must get the lowest possible number, right? Means suppose this is rule number 3. Now I am explaining. Suppose if you start from this side, so the first position is this, you cannot start from in between anywhere, like you're going to start from this carbon or this carbon or this carbon. You have to start from the terminal carbon, either this carbon or this carbon. So you start from here, 1 2 3 4 5 6 and 7 carbon atom. Now if you number from this side, the position of locants, we say this locants present at 4th carbon, this locants present at 5th carbon, and this locants present at 6th carbon, right? So what is the sum of locants we are getting here? That will be 4 plus 5 plus 6, which is 15. This is one possibility. Another possibility is what? If you number the carbon atom from this side, right? So what happens if you number the carbon atom from this side? You see 1, 2, 3, 4, 5, 6, and 7. So if you number from this side, the position of locants are 2nd, 3rd, and 4th. This is 9. So this rule 3rd says what? We have to follow, or we have to consider the lowest set. Which one is the lowest set? Here we are getting 9. Here we are getting 5. So we consider the 9th one, not this one. So numbering, this yellow one numbering is not true. So this we do not consider. This we have to ignore. Because we are getting more number here, 15 we are getting. But the red one, from this side we are getting only 9. So this is the correct numbering. Did you get it? Is it clear? The same rule, if I explain you with the simplest example, suppose I take this one. The same rule number 3. 1, 2, 3, 4, 5, and 6. Here we have suppose some substituents, which is chlorine suppose attached here. Now obviously we do not have any other choice, but the longest chain is this. This is the longest chain we have. So principal chain is this. Longest chain, principal chain is this. Now when you start the numbering from this side, it will be 1, 2, 3, 4, 5, and 6. And if you start the numbering from the other side, you'll get what? 1, 2, 3, 4, 5, and 6. So from this side, the yellow one, the position of locants is at 4th carbon, and the red one, the position of locants from this side is at 3rd carbon. So we'll follow the lowest set of locants, which is 3 is correct here. Hence, this numbering, if you do, this will be wrong. The yellow one is wrong. The correct one is the red one. Okay. So what is the name of this compound? Now you have selected the longest chain. You have given the position of the locants, right? So now you can name the compound here. So this will be the name of this compound. We have 6 carbon atom, 6 carbon atom. So root word is what? Hex, right? And there is no double bond, only we have single bond. So the primary suffix is what? The primary suffix is ane, right? Right, primary suffix is ane. There is no other suffix present here. So we'll write hexane. But on this hexane, third position, we have chlorine here. So this is the prefix. So we'll write here 3-chloro. So this is prefix, root word, suffix, and this is the name of this compound. How many of you understood this? This is the basics of nomenclature. The same thing you have to apply for all other compounds. Yes, wait. Understood this? One more thing you must take care of. There should not be any space, or we cannot write this in capital letter. If you write this, you'll get 0 marks in school, right? So the name of this compound, if I write down, that will be 3-chloro and hexane, without any space, without any, we do not have any capital letter in between. So this is the correct name. This is even wrong. This is even wrong because you have given space here and one capital letter you are using. Correct name is this. Yeah, I'll go to that question. All of you understood this, correct? The easier one. Okay. Now, like most of you are asking for the previous questions, I'll do this one also. Okay. So now we have already selected the longest chain. We have done the numbering, and at second and third position we have methyl. What is the name of this substituents which is present at the fourth carbon? Yes, it is propyl. Okay. So what we have here, you see, we have 2 methyl group. Just a second. Here we have 2 methyl group. So we can write for this dimethyl because we have 2 methyl groups, so dimethyl, and 1 propyl group we have. Okay. So when you write down the substituents, because we have 2 different substituents here, so we write down the name of the substituent first, which comes alphabetically first, right? We have to compare this M and P. Which comes alphabetically first, M or P? M. So we'll write dimethyl first and then we'll write propyl. We'll write dimethyl with its position and then propyl with its position. Don't get confused here, sir, why you are not considering this D here. This di, tri, tetra term, we do not consider in this. We will consider this, but that is a different case we have. I will explain that later. Okay. This substituents, this di, we are not considering this D of di in alphabetical sequence. Alphabetically, methyl comes first, then propyl. So we'll write dimethyl first with its position and propyl first. After that, we'll write propyl with its position. So name of this compound is, we have dimethyl at second and third carbon. So the name is 2,3 dash dimethyl. Okay, 2,3 dimethyl, and then we have at fourth position we have propyl. So we'll write dash 4 dash propyl. There should be no space. And then we have 7 carbon atom. So for 7 the root word is hept, and there is only single bond, so ane. This is the name of this compound. Doubt? Doubt? See, one more thing you can take care of here, that you see here, observe this thing. The numbers are separated by comma. The numbers and the letter 3 and D are separated by a dash, hyphen, right? So if you write down hyphen here and comma here, again you'll get 0 marks. This is very important, okay? If you are writing down multiple choice question, if it is there, you have to select the option. Then all these things does not matter, because options are given there, you have to choose that, okay? Right, but if you have to write down the name of this compound, like the question you get in your board exams, in your school exams, then you must take care of where we should place the hyphen and where we should write down this comma, right? So always keep that in mind. Numbers are separated by comma. Numbers and letter are separated by hyphen. Got it? It is propyl because we have 3 carbon, meth, eth, prop. So we have 3 carbon. So it is attached to the ring. So it becomes alkyl now. See, I'll tell you one thing. When you have alkane, just say, suppose you have methane, right? So when you remove one hydrogen from methane, it becomes methyl, right? You remove one hydrogen from propane, it becomes propyl. So what happens? This was actually propane. What you did, you removed one hydrogen, it becomes propyl, and then it attached to this chain. That's why it is propyl. Okay. Could you name this compound? I'll just write down just a second. So these are the rules actually. The basic rule is this only, but the actual, understanding of nomenclature and the key points that we have, that you will get once you solve the question, okay? Without practice, you won't understand this. Like as far as theory is concerned, we have nothing. Just you select the longest chain, number this, and then write down the name. But the things, how the things changes with different compounds, that you will get once you solve the question, okay? So the next compound, can you write down the name of this one? CS3CH Br CHCH3 Cl. Tell me the name of this compound. The name of these two compounds. 2-bromo-3-chloro pentane it is. Okay, so longest chain is this. Obviously, we have 4 carbon atom in this chain. When you start numbering this, you can start either from this side, 1, 2, 3, and 4. And if you start from the other side, it will be 1, 2, 3, and 4. Right? So here you see the sum of locands from this side, the white one or the red one. Suppose I write down first. The sum of locands from right to left side is R to L. Right to left. The sum of locands is 2 plus 3, 5. And the white one is from left to right if you go. The sum of locands is what? 2 plus 3, which is again 5. Now you have equal values of this, right? When it is equal value, then you cannot go by lowest sum of locants rule because the values are coming to be same. So in this case, what happens? The locants or substituents which comes alphabetically first will give the lower number to that locant. Are you getting it? Are you getting it? What I said, 2 and 3, the position of bromine. Like this, if you go, the position of bromine is 2. If this side is 3, sum of locants is same. So when the sum of locants is same, then we'll give the lowest possible number to the locants which comes alphabetically first. Correct? So bromine and chlorine. Bromine comes first, then chlorine. So we should give the lowest possible number to bromine, not chlorine, right? So correct one is what? Correct one is left to right, not from right to left. So this is correct. This is wrong, right? So name of this compound will go by the numbering, which is the red one, which is white one, which is this. So it is 2-bromo, 3-chloro-butane. So we have 2-bromo dash 3 dash chloro butane. Did you understand this? First one, did you understand? First one, guys, did you understand the first one? The longest chain in the second one is this. Okay. Now in this, we'll start numbering from which side? This side or this side? See, we'll try from both sides. You see what we are getting. If we start from this side, we get 1, 2, 3, 4, 5, and 6. So at fourth position, we have ethyl, and at second position, we have dimethyl, 2-methyl group. Correct? If you start from the right side, we get 1, 2, 3, 4, 5, and 6. So right side, right to left, you see, we are getting what? 5 plus 3, that is 13. Since we have two substituents here, 2-methyl groups, so I add this 5 twice. Okay, right, left to right, if you go, the red one, you see we are getting 2 plus 2 plus 4, that will be equals to 8. So lowest sum we have from left to right, right? So this one is right and this one is wrong. So white wala is not right. We'll consider the red one. So the answer for this one is what? 2-dimethyl, 4-ethyl. So we'll write down E first, then M. So 4-ethyl, 2, 2 dimethyl hexane. Again, you see here, in this only you write down this D, write down here, like this only you write down here. We do not consider di, tri, tetra, etc. We do not consider di, tri, tetra, etc. into alphabetical sequence. Yes, Shitish. Into alphabetical sequence if the substituents is not complex. If the substituents is not complex, okay? Don't ask me what is complex substituents. We'll discuss that later. Today we won't discuss that, okay? So let it be as of now. These are simple substituents actually, okay? What is this thing? Complex substituents, we'll discuss that later. If complex substituents is not given, then this di, tri, tetra, whatever we are getting here, this D or T of that, we won't consider into alphabetical sequence, correct? So we have to compare here M and E. E comes first, so we'll write ethyl first and then methyl. Clear? Write down the name of these compounds. Now we'll see some examples. Okay, we have discussed the rules. Other things we'll understand by examples only. Tell me the name of this compound. I'm sorry, wait. What is this? Write down the name of these three compounds. No, I'm not, Shitish. Yeah, it is swastika. What is this structure? What we call it as? What is this representation actually? What is the name? All these structure that I have written. What is the representation called? We have done no three. Yeah, it's bond line notation, correct. All these are bond line notation. So you remember that in bond line notation, we do not represent carbon hydrogen bond. Okay, all the corners and the intersection points, we consider there's a carbon. Okay, so the longest chain, first of all, we'll select. That will be 1, 2, and 3. What we can write? 2, 2 dimethyl propane. It's not pentane, Ansh. See, the root word will be according to the longest chain. It's not the total number of carbon atom. Okay, so longest chain has 3 carbon. So root word is prop. Name of this compound 2, 2 dimethyl propane. Okay, 2, 2 dimethyl propane without any gap space. Now in this one it will be 1, 2, 3, 4, and 5. What is the name? 3, 3 diethyl pentane. Yeah, it's correct. At third position we have 2 ethyl group. Right, so it will be 3, 3 diethyl pentane. This one is 1, 2, 3, and 4. What is the name? Yes, it is 2,3 dimethyl butane. This is the name of this compound here. Okay, the last one for today is CCl3 CH3. CCl3 CH3. What is the name of this compound? Okay, Shreya is getting 3-chloroethane. Now Shubhi is getting trichloroethane. 111 trichloroethane. Okay. Yeah, the name is correct. Guys, you see, like, you don't have to write down the number here. See, just like those who could not do this question, you know, the compound is the derivative of this actually. And it is an ethane. Simple compound, it is an ethane. What happens if I replace one hydrogen by one chlorine? So it is CH2Cl, CH3. So it is chloroethane. This becomes chloroethane, one chlorine is there. What happens if I replace two hydrogen by two chlorine atom? This becomes dichloroethane because two chlorine atom is there. So dichloroethane. Similarly, if you replace this hydrogen by Cl, again it becomes CCl3CH3. So it becomes trichloroethane. Chloroethane. You can write 111, but that is not required because we have only 2 carbon atom. So whether you write this Cl3 here or this Cl3 on the left side, that does not make any difference, right? So these are the name of these compounds here. So did you understand the concept we have discussed? A few things today for organic chemistry. Did you understand all those stuffs? Yes. So what we do, you have a test on Sunday and we'll have a questions on this thing only, whatever we have discussed today. Okay, you'll get a questions on this one. It will be multiple choice question. You'll have 4 options, right? And 1 correct will be. Okay. Okay, guys, thank you. We'll wind up the session here, including DBE, whatever. Yeah, DBE also. Everything, whatever we have done today, everything will be there. Okay. Thank you, guys. Thanks a lot. See you in the next class. Bye-bye.